3.6, a summary of curve sketching. So we're going to put everything together, alright? Let's look at my equation here. I have y equal to negative 1/3, parenthesis, x to the cube minus 3x plus 2, close parenthesis. I'm going to distribute minus 1/3 in, and this is what I get, alright? As you look at the equation, this is degree 3, right? The leading coefficient is negative. So the graph will look something similar to this, alright? Just from pre-cal, this is degree 3. Leading coefficient is negative, it's going to rise on the left and fall on the right. And you're going to have at most 3x intercept. It might not be 3, but at most, alright? And you're going to have at most 2 turning point. So again, at most mean can be less. So 2 turning point. This is a turning point from going down to going up. So to graph this, you need server information. You need the x-intercept. To get x-intercept, you're going to have to set y equal to 0 and solve for x. You need to have y-intercept. To get y-intercept, you need to set x equal to 0 and solve for y. You need a critical number, alright? To get critical number, you need to take derivative, and see if it's greater than 0 in that region, it's increasing. If it's less than 0 in that region, it's decreasing, and if it's equal to 0, it's constant, alright? Relative max and relative mean, you can use the first derivative is if it's from increasing to decreasing, so the relative max. From decreasing to increasing, so relative mean. Or you can use the second derivative test, which means you take the second derivative and plug in the critical number, and either is greater than 0, which means it's relative mean, or less than 0, which is relative max. You also need to find the point of inflection and concavity, which means you have to use the second derivative. Alright, now let's continue our example. Okay, first I'm going to use this equation instead of the top one. Alright, I want to get rid of denominator, so I multiply every term by negative 3. By doing that, I get rid of denominator. And I'm going to use synthetic because it's degree 3, alright? If you don't remember, synthetic is from pre-cal, alright? However, I'm missing some term. The degree is not in decreasing order. I'm missing x squared, alright? So I'm going to put 0 times x squared. So now I have every degree in decreasing order. Make sure that you put everything in order. If something missing, just put 0 times that degree, alright? So I have coefficient is 1, 0, negative 3, and 2. My P is 2. So possible factor of 2 will be plus or minus 2. My Q is 1. Possible factor of 1 is just plus or minus 1. So P over Q is just plus or minus 1, plus or minus 2. So you have 4 combinations. Plus minus 1, plus or minus 2. I'm choosing 1 and it worked out, alright? Bring down the 1. 1 times 1 is 1. Combine these two terms is 1. 1 times 1 is 1. Combine these two terms is negative 2. 1 times negative 2 is negative 2. Combine these two terms is 0. This is the remainder. So the factor of x to the cube minus 3x plus 2 will be x minus 1 times, so this will be the coefficient of your next polynomial, which is degree 1 less than this. So it's going to be x squared plus x minus 2, and this is the remainder, which we don't have to worry about. Now I have degree 1, degree 2. This is quadratic. I can solve it some more by factoring. So if I factor x squared plus x minus 2, I have x plus 2, x minus 1. Solve for x, so my x will be 1 and negative 2. This is my x-intercept. This is where the graph will cross the x-axis. Now the y-intercept is pretty easy. If you substitute 0 for x, the y will be negative 2/3. That is the y-intercept. The next step I'm going to do, I'm going to find a critical numbers. Could be more than one. So from the original equation here, I take derivative. First derivative, I will have negative x squared plus 1. Set it equal to 0. Solve for x. So my critical number, I have plus or minus 1. Next step I'm going to do, I'm going to find point of inflection. I take the second derivative of this, which is negative 2x. Set it equal to 0. My x would be 0. And my y, if you plug it in, will be 2/3. If x is 0, y will be negative 2/3. Alright, that's the point of inflection. Alright, we have x-intercept, which is what? Negative 2 and 1. This is x-intercept. I have y-intercept, which is 0, negative 2/3. That's my y-intercept. Now I'm going to divide my region from the critical number, negative 1 and 1. If you look at the interval from negative infinity to negative 1, from the first derivative, which is this, plug in any number in this region. I choose negative 2, plug it in, I have negative number, which is decreasing, right? From the second derivative, which is this one, in this region, I plug in negative 2 as well, then I have 4, which is positive, which means it's concave up and decreasing and concave up. Use the first derivative. Now if you use the second derivative, you will plug in the critical number. Oh, that's for relative mean. Let's go to next one. Okay, the next region is from negative 1 to 0. I do the same thing. First derivative is increasing. Second derivative is tell me it's concave up. So I'm going to have a curve increasing and concave up. Okay. The next one, the region from 0 to 1, first derivative, I'm going to have increasing. Second derivative is concave down. Concave down. And increasing. The last region from 1 to infinity, plug in the first derivative, I have decreasing, second derivative is concave down. It looks like so. Let's see, what am I missing? Relative mean. Okay, relative mean, if you've used the first derivative test, you see it's decreasing and then increasing. That's the first derivative test. It tells you relative mean. If you use the second derivative test, you plug in the critical number here, then you're going to see it's greater than 0, so it's relative mean. Let's look at this one. If you use the first derivative test, you see this is increasing and then decreasing, so it's relative max. If you plug in a critical number in second derivative test, you see it's negative, so it tells you a relative max. Alright, so this is everything that we cover, put it together. So I hope you practice doing a lot of homework, and I'll see you later. Bye.